Okay, folks, buckle up. Get ready for a deep dive into something you probably hear about all the time, but maybe don't really understand.
Sounds intriguing. What's on the agenda today?
We're tackling the matrix.
Yeah.
But before you start picturing Keanu Reeves dodging bullets in slow-mo,
Yeah, I was about to say.
we're actually talking about the mathematical kind of matrix.
The real deal.
Exactly.
Yeah.
But don't worry, you don't need a PhD in math to follow along. We'll break it down nice and easy. We've got some great resources lined up to help us explore what matrices are, why they matter, and where they pop up in everyday life. You ready to dive in?
Absolutely. Let's do it.
All right, so let's kick things off with the fundamental question.
Uh-huh.
What exactly is a matrix? I mean, I know I'm looking at rows and columns of numbers, but what's the big picture here?
So a matrix is basically like a rectangular grid. It's got these rows going across and columns going down, and each little box in that grid, each element, well, it holds a number or a symbol or sometimes even a whole expression.
Okay, so kind of like a spreadsheet
Mhm.
or like a tray of cookies, maybe.
Exactly. That's a great analogy. Each cookie would be an element, and it has a specific address based on its row and column, like a coordinate system for data.
I like that. So if I want that double chocolate chip cookie in the third row, second column, I know exactly where to go.
Precisely. It's all about organization. And that's what makes matrices so powerful for all sorts of calculations.
Got it. But earlier you mentioned not all matrices are created equal, so we're not just dealing with one giant cookie sheet here, right?
Right. There's actually a whole variety of matrix types, like square matrices, for example. They have the same number of rows and columns, so they look nice and symmetrical.
Ah, so they're like perfectly square brownies. Makes sense. What other kinds of matrices are there?
Well, there's the identity matrix, which is a special kind of square matrix. It's got ones all along the main diagonal and zeros everywhere else.
Okay, so that sounds kind of specific. What's so special about it?
It's like the matrix equivalent of the number one. If you multiply any matrix by the identity matrix, you get that same matrix back. Nothing changes.
So it's like a neutral player in the matrix world. It doesn't mess anything up.
Exactly. And that property is super important in linear algebra, especially when solving systems of equations, like trying to figure out, say, how much of each ingredient you need to scale up a recipe.
Right, because you don't want to accidentally double the sugar and end up with a cake that's way too sweet.
Exactly. The identity matrix helps ensure everything stays balanced.
Okay, makes sense. So we've got the square matrix, the identity matrix.
Hmm.
What about the zero matrix? That one sounds pretty straightforward.
It is. It's literally just a matrix filled with zeros, kind of like a blank canvas for matrix operations.
Got it. So we've met some of the key players in this matrix family, but we can actually do stuff with these matrices, right? It can't just be about arranging numbers in a grid.
Oh, absolutely. We can perform operations on matrices just like we can with regular numbers. We've got addition, subtraction, and scalar multiplication.
Okay, I think I remember scalar multiplication from math class, but remind me how that works again.
Sure, so let's say you have a matrix and you want to double every value inside it. Scalar multiplication means you're multiplying each element by a single number, in this case 2.
So it's like turning up the volume on the entire matrix, making everything bigger or smaller.
Exactly. It's like applying a zoom to the entire matrix.
Cool. But now, I gotta ask about something I've heard is a bit more challenging. Matrix multiplication. It sounds intense.
It is a bit more complex. Instead of just multiplying each element by a number, you're actually multiplying rows and columns in a very specific way.
Oh boy. I can already feel my brain starting to hurt. Can you give me an example to make it a little less abstract?
Let's think about video games for a second. Say you want to rotate an object on the screen. You can actually use matrix multiplication to do that.
Wait, really?
Yeah. One matrix would represent the initial position of your object, and another matrix would represent the rotation you want to make. You multiply those two matrices together, and bam! You get a new matrix that describes the object's new rotated position.
Wow, so those amazing graphics I see in my favorite games, that's partly thanks to matrices.
Absolutely. And that's just one example. Matrix multiplication is also incredibly important in data science and machine learning.
Oh, how so?
Well, think about those algorithms that recommend products or movies you might like based on your past activity. They're crunching tons of data, looking for patterns, and using matrix multiplication to make those predictions.
So that's how Netflix seems to know me better than I know myself. It's all matrices behind the scenes.
Exactly. And let's not forget cryptography, where matrices are used to encrypt and decrypt sensitive information, like when you make a purchase online.
So they're like the guardians of our data, making sure it stays safe and secure.
Exactly. And this is really just the tip of the iceberg. Matrices are everywhere, from engineering and physics to economics and medicine.
Wow, I had no idea they were so fundamental to so many fields.
They are. They're like a hidden language that helps us understand and solve complex problems in tons of different areas.
It's amazing to think something that seems so abstract on the surface, like rows and columns of numbers, can have such a huge impact on our world.
Right, and that's the beauty of math. It often seems very theoretical, but it's what makes so much of our technology and modern life possible.
Totally. Well, you've definitely given me a whole new appreciation for the power of matrices. To everyone listening, the next time you're playing a video game, browsing online, or even just looking at some cool special effects in a movie, remember those hidden matrices at work behind the scenes.
It's true. Matrices are everywhere, quietly shaping our world.
Exactly. And who knows, maybe understanding a little bit about them will inspire you to dive even deeper into the world of math and see what other amazing things you can discover.
That's what we're here for, to spark that curiosity and get people excited about the incredible power of math.
Absolutely. So keep those matrix eyes peeled, folks. You never know where they'll pop up next.
And that wraps up another deep dive. Until next time.
See you then.